The next thing we're going to look at with the antiderivative is something called an initial value problem. And basically what this is we're given a derivative function, and we're again going to work backwards to find the antiderivative by taking the indefinite integral. But the main difference here is that we're going to be given some initial value, which is going to help us figure out the exact c value for our particular problem. So we're just going to look at a couple of these examples. So this first one, we're given our f prime function is 1 over x squared, and we're given this initial condition that f of 1 is equal to 0. All right, so we want to find f of x. So our f of x function would be the indefinite integral of 1 over x squared dx. And of course, we can rewrite that as the integral of x to the negative 2 dx. All right, so then we're thinking opposite of power rule. So add 1 to your exponent, should be a negative 1, and then multiply by the reciprocal of that out front, which is still just a negative 1. And of course, that comes along with our plus c. Now, you always have that constant of integration. Okay, so that's typically where we would leave a problem like this. But on this one, because we're given this initial condition, that f of 1 is equal to 0, we can use that piece in order to find our c value. So I'm going to go ahead and just rewrite this first of all as negative 1 over x plus c. Okay. All right, so f of 1 is equal to 0. So we're saying here our function is equal to 0 when our x value is equal to 1. And of course, if we solved that out, that would tell us that c is equal to 1. So our final function here then is f of x is equal to negative 1 over x plus 1. All right, so when we're given an initial condition, we're able to plug it into the function and find the c value. All right, so let's look at another example like this, but this time in terms of an application. All right, so here we're looking at that position equation that we visited in a previous unit. So we're told that a ball is thrown upward with an initial velocity of 64 feet per second and an initial height of 80 feet. And we're assuming here that our acceleration equation is negative 32. Okay, so in order to find the position equation, which is what we're looking for, find the position equation of the ball, we're first going to want to find the velocity equation, and then we can find the position equation. So we're going to work our way backwards from acceleration. All right, so first of all, the velocity would come from taking the integral of acceleration, okay, which is just the integral of negative 32 dt. All right, and that would just be negative 32t plus c. Okay, now again, we can find that c value given our initial information here. So it tells us that the initial velocity was 64 feet per second. So that's saying that v of 0, initial meaning times 0, is equal to 64. All right, so that's saying if we plug in 64 for v of t, we plug in 0 for t, we would of course get our c value is 64. All right, so that's telling us that v of t is equal to negative 32t plus 64. All right, now remember our goal though is to find the position equation. So just like we integrated acceleration to find velocity, if we integrate velocity, we'll find position. So our position equation is the antiderivative of the velocity equation. So the integral of negative 32t plus 64 dt. All right, so just power rule here. you have negative 32, add 1 to your exponent, so it'd be a t squared, and then multiply by the reciprocal to balance that out, and then plus 64t plus our constant of integration. All right, and then let's go back to our given information here. So it told us that we have an initial height of 80 feet. That's telling us that S of 0 is equal to 80. So if we plug in 80 for S of t, plug in 0 for t, we would get C is equal to 80. So finally, putting everything together, S of t would be equal to negative 16t squared plus 64t plus 80. And that would be our final equation.